We want to welcome everyone to this side event on Kratom. My name is Matt Caddo, Senior Fellow on Public Policy with the American Kratom Association. And we welcome those here in the room, and we're live streaming and recording this side event. The American Kratom Association has always had a commitment to good science driving both the consumer behavior and public policy. And in fact, that science informs both manufacturers on the safe formulation of Kratom products that should be available to consumers, and consumers so that they know what the dosage limits are, serving sizes for Kratom products that can be safely ingested. And equally important, science should inform the public policymakers around the globe on how they should, in fact, regulate Kratom, and why we believe that Kratom is appropriately regulated as opposed to being prohibited. And so we welcome here some of the leading scientists in the world who have researched Kratom and inform all of the stakeholders in this process. We're going to hear today in this order from Dr. Christopher McCurdy at the University of Florida, Dr. Edward Boyer from Ohio State University, Dr. Darshan Singh of the University of Malaysia, Dr. Marilyn Eustace from Thomas Jefferson University, and Dr. Kirsten Smith from Johns Hopkins University. We also welcome in the room Dr. Jack Hennifield from Johns Hopkins University, who presented in a side event with the Czech Republic earlier this week, discussing Kratom and their policy formulation as it relates to regulation versus prohibitions. So we'll lead off with Dr. McCurdy.
Thank you very much. It's an honor to be here and share some of our research with you, as well as some of the research of others. And I'm going to just start off to give a quick overview of kratom use in Southeast Asia, although Dr. Singh will go into this in much more detail. But this comes from a tree that's used by field workers in Malaysia, also in Thailand, to relieve pain as a stimulant to improve their work capacities and to reduce opioid withdrawal, which will focus most of my comments around. In Thailand, the leaves are chewed, so very similar to how coca leaf is used in South America. And most raw kratom materials in the United States are actually coming from Indonesia. The predominant active ingredient is mitragynine or mitragynine. It's a coinant alkaloid that is comprising about 66% of the total alkaloid content of the plant material. There are several alkaloids that have been isolated and reported on. Our lab has done some of the most extensive screening on these alkaloids for pharmacological activity. And what we've learned from that is kratom actually has multiple pharmacologies associated with it, not just opioid, which many people have attributed to, but it has surprisingly strong activities from serotonergic systems as well as adrenergic systems. And all three of these systems are involved in pain transmission. And so it's understandable why this is a popular remedy traditionally for pain, but also they cause stimulant-like activities. And it's also being used in that capacity. So these are just some of the alkaloids. I won't go into them in detail other than to show you that they look very similar. Because the plant biosynthesizes all of these in a similar format. The plant actually, we believe, uses these alkaloids to protect itself from fungal infection. We think these have antifungal activity, and the plants grow in very wet environments and sometimes can be in standing water. This is the receptor pharmacology of many of the major alkaloids that have been isolated from the plant or are actually metabolites that are known to be active. 7-hydroxymitragynine, 9-hydroxychlorantraniliprole, and 7-hydroxypananthine at the bottom are all active metabolites. Mitragynine, pananthine, speciosialacine, chlorantraniliprole, corinoxine, speciogynin, corinoxine B, ashmalacine, and isospeciophyllin are all isolated natural products from the plant itself. And what we did was screen each of these at a very high concentration, which is what you see in black on the right. All of those high concentrations hit multiple targets within the central nervous system. As we decrease that concentration, you can see that we hone in on mostly opioid receptors, serotonin receptors, and adrenergic receptors, which are the primary drivers of the complex pharmacology of the plant. For therapeutic use, we've been focusing on opioid detoxification for actually replacing several medications at once, or a medication-assisted therapy, very similar to how buprenorphine is used. We do know that kratom withdrawal is mild, and that will be addressed as well during this panel. The lack of real standardized products has delayed clinical trials to really evaluate these claims in the U.S. However, what we've done in animals and preclinical settings is looked at nociception, so pain, and where we're looking at these animals and treating them with either morphine, which you can see in red or green, and lyophilized kratom tea. So we make a kratom tea just like it's made in Malaysia, and then we freeze dry that and feed that back to the animals. And what you can see is it's much less potent than morphine in its overall analgesic effects, but it reaches sort of a ceiling around 1 milligram per kilogram up to 1 gram per kilogram up to 4 grams per kilogram with about equal efficacy. We also know that the tea in its analgesic effects last for quite a long time, just about over an hour, with a typical dose that was fed back towards what human dose would be. It also lacks a condition place preference. This, in short, is a drug-seeking behavior. So animals do not seek to find this, to take it. It also reduces precipitated withdrawal with naloxone quite drastically when it's compared to morphine, the traditional opioid. And then last thing I wanted to show you was more recent data where we actually see some excitement around mitigation of methamphetamine self-administration without affecting food intake. This is very promising and aligns well with some of the data coming out of Malaysia showing that kratom is actually reducing methamphetamine intake. So that's all I have.
Hello, my name is Edward Boyer. I'm a medical toxicologist. We're the smallest of all medical subspecialties. So we focus on poisonings, overdoses, adverse drug events, drug interactions, and literally anything in non-human that can affect humans. So when I don't have slides. So when I think about the adverse events of kratom, they generally fall into, right now, two main areas. They fall into seizures, they fall into cardiac effects, where you develop a cardiac dysrhythmia. And I just want to give you guys sort of my super fast analysis of why I don't think you can hang those adverse events on kratom. Yeah, like when you think about mitragynine as the predominant alkaloid, it's got 5-HT2, that's serotonin binding, 5-HT2A and B, which is a site where SSRIs work. It's got MOR, mu opioid receptor activity, and it's also got central acting alpha-2 agonist activity, such like clonidine, guanfacine, or dexmedetomidine. So if you think, if you believe, as medical toxicologists do, that there has to be a mechanism of disease, there has to be something in a substance that causes the outcome, we need to go back and look at the pharmacology. When I do my analysis, I think about what would happen if I overdosed on the particular drugs, that have the same pharmacology. So 5-HT2A and B, that sounds like serotonin syndrome. Serotonin syndrome is not associated with seizures. It can be confused with seizures because you develop a tremor in the lower extremities more than the upper, but you do not seize unless you have hyperthermia from increased muscle tone. The seizures that happen because you're hyperthermic, not because you have serotonin syndrome. So the serotonergic activities of mitragynine, and by extension kratom, are insufficient to cause seizure activities. Well, how about MOR? MOR, the mu opioid receptor agonistic binding does not cause seizures. It might in withdrawal, but only in neonates. After you pass out of the neonatal period, seizures do not occur in isolated opioid withdrawal. So again, we don't have a mechanism to point at mitragynine. And lastly, 5-HT2A, in the United States, it seems like so many people are maintained on either clonidine or guanfacine for ADHD, we have people overdosing on these medications all the time, or certainly overusing them, and that's not a cause of seizures. That's not part of the toxidrome, the clinical presentation of toxicity that occurs with that class of drugs. Now, if you look at people who have seized while taking kratom, generally one of two things has happened. They either have a seizure disorder, which is undertreated, or which may be undertreated, I should say, or they've taken proconvulsant substances, drugs which on their own are associated with convulsant activity. In individuals who don't take a medication that's proconvulsant, who do not have an existing seizure disorder, and you do an EEG on those folks, you actually get brainwave patterns out of them. Those folks seem to have a focus of seizure activity, which just hasn't led to seizures up to that point. So we're looking at the first seizure, not a kratom-caused seizure. So if you're going to hang your hat on kratom, you need to do a lot more research to prove that there's causation. Right now, it simply doesn't exist. On the cardiac end, the data is much more sparse, but kratom does not cause sodium or significant potassium channel activity, which are the general causes of ventricular tachycardias of most forms. So if it doesn't have those activities, finding a mechanism by which it could cause ventricular tachycardia, torsade de pointe, or some other cause of a ventricular dysrhythmia is lacking as well. So to summarize, I don't believe that there is sufficient data to establish causation that kratom or mitragynine causes the adverse events that are associated with it. And in fact, I think when you look at the small number of people who've had seizures in the context of kratom use worldwide, and we're only talking maybe 30 people, we're probably just looking at the background incidence of seizures in general. And with that, I'll stop.
I can actually start without the presentation, without the slides. Is that okay? Yeah. That you can actually troubleshoot. So, good morning. My name is Darshan Singh. I'm from University of Science Malaysia. So, I strongly believe that all of you know exactly what kratom is. Kratom is a native medicinal tree of Southeast Asia. All right, so it is a native medicinal tree of Southeast Asia, and it can be found growing abundantly in the community, although a substantial number of individuals have started planting kratom on land designated for commercialization purposes due to the increasing demand for kratom leaf material. Now, rural inhabitants in Southeast Asia who grew up with the deep-rooted traditions have continued to use kratom for a myriad of health benefits, and not only as a stimulant, but to treat a plethora of health maladies. Now, indeed, kratom saga is no different than the long contested cocaine using controversy. So while laws banning kratom use have been around in Southeast Asia for a very long time, existing laws still provide some leeway for people to use kratom in Southeast Asia. For example, today, kratom is legal in Thailand. In Indonesia, laws are being amended to allow kratom export, whereas in Malaysia, authorities have tried numerous times to impose a permanent ban on kratom, and the thing that concerns drug enforcement authorities overwhelmingly is the occurrence of kratom co-consumption with illicit drugs and the erroneous perception that kratom serves as a gateway drug. Despite the sanction, dwellers in rural settings continue to use kratom unrestrictedly as part of their tradition. Now, we cannot brush aside kratom's dependence-causing risk. This is because it is scientifically shown to have some degree of limitation. However, kratom's dependence-causing risk is not viewed as something destructive or detrimental by traditional users who have been using kratom for centuries in Southeast Asia. Let me highlight that in Southeast Asia, kratom consumption has not caused any major health burdens thus far, except for some minor health complications believed to be compounded by adulterated kratom use. Now, despite kratom's broad therapeutic applicability, the native medicinal plant has appeared extremely appealing among those struggling to abstain from illicit opioids and polydrug use. So in Southeast Asia, people who are dependent on heroin and crystal methamphetamine, they actually use kratom as a substitute and to also self-treat their dependence on illicit drugs. Now, notably, current evidence have categorically shown that kratom promotes self-treatment, and those dependent on illicit drugs were able to break free from the vicious cycle of addiction without having to enroll in oppressive rehabilitation programs infamously known for its human rights abuses. Indisputably, kratom initiation was associated with a marked reduction in the use of illicit drugs in Southeast Asia. I know that this statement could sound far-fetched. Indeed, it is real because we have done a number of studies and we have shown clearly that people who have been using kratom, they were able to actually give up illicit drugs easily. In summary, kratom is still largely used for its medicinal value in Southeast Asia, though authorities persist to frame kratom negatively. To the best of my knowledge, so far kratom consumption has not caused any deleterious health issues, which calls for immediate health prevention interventions. People who use illicit drugs, like I was telling you just now, people who are dependent on heroin, crystal meth, and cannabis, have greatly benefited from kratom, though these testaments awaits to be recognized with human clinical studies. To conclude, it is unfair if kratom policies are exclusively constructed based on anecdotal data. In fact, policies around kratom regulation must be formulated through science, through sound scientific evidence. With that, I end my presentation. Thank you very much.
Good morning. I'm Marilyn Hustis from the United States and Thomas Jefferson University. And today I'm going to be talking about the safety of kratom and new data, both epidemiological data and controlled administration data in animals and in humans. So first, from the FDA, their adverse event reporting system gives you some idea of the number of reports of adverse events related to mitragynine. And you can see in green, and it's similar to the number of adverse events reported for caffeine. And obviously much, much lower than the other problematic opioids. You know, we have a terrible opioid epidemic in the United States. So this is some of our first work on rats. We followed the FDA recommended protocol for evaluating respiratory depressant activities in animals, and they suggested using oxycodone as the positive control. We have 3 doses. The first is the therapeutic dose, the 6.75 milligrams per kilogram. And you can see that we, at the 2 higher doses, had significant increases in the partial CO2 pressure, showing respiratory depression, and significant decreases in the oxygen saturation. And if you look, you saw from Dr. McCurdy's work, we dosed up to 400 milligrams per kilogram, really high mitragynine doses. We had no significant change in respiratory depression. This is a manuscript that came out in very late 2023. It's from the largest forensic drug testing lab in the world, and they had many driving under the influence of kratom cases, 127, and they had over almost 5,000 postmortem mitragynine cases. In greater than 90% of those cases, they had less than 1,000 nanograms per mil of mitragynine, and they had intoxicated drivers with concentrations up to 1,000 nanograms per mil. And these are live human beings, yes, intoxicated, but nowhere near death. So they suggested that any concentration less than 1,000 nanograms per mil of metragine was highly unlikely to be associated with adverse events, including death. And yet around the world and in the United States, we have medical examiners and coroners reporting kratom deaths at low levels. It's actually as low as 30 nanograms per mil. And as you can see, we have individuals that are driving impaired at up to 1,000. We recently completed the largest and most comprehensive human kratom clinical study. We had more than 200 participants. We had 3 different kratom formulations, 4 doses, escalating doses. We studied a single dose of kratom and monitored all adverse events and pharmacokinetics for 10 days. And then we had 15 consecutive daily doses that we monitored again. I'll show you what we monitored. A very intensive study following up the chronic dosing for 23 days. You can see that we monitored both chemistry, hematology, adverse events, respiratory, cardiovascular, cognitive. We monitored many aspects looking for the adverse events. What we found is after 15 daily 4,000 milligram kratom doses that contained up to 53 milligrams of metragine, we reached plasma concentrations up to 215 nanograms per mil. And when they received the higher metragine isolate dose of 15 daily doses up to 89 milligrams, we have concentrations up to 753 nanograms per mil in volunteers who are working and who are going to school, and they come in and get every dose was observed. We had no serious adverse events, and they went back to work or school. So in conclusion, it's critical that comprehensive toxicology be performed in these, quote, kratom-caused deaths, because in more than 90% of these, we find multiple other drugs, including potent opioids like fentanyl, oxycodone, antidepressant drugs, benzodiazepines. So one of the biggest issues we've seen is where there's limited testing. They find the kratom in the home where the individual is using it to help control their illicit drug use, opioid use, benzodiazepine use, etc. And most of these deaths, the individuals have multiple drugs on board and have a history of illicit drug use, and including novel psychoactive substances, which of course is a big topic of discussion here at this meeting. And most labs do not test for NPS. When we have drug cases where we can go back and do more comprehensive toxicology, we almost always find the presence of other drugs. There's a lot of new data, both epidemiological and controlled drug administration data, to inform pathologists and medical examiners of the effects of kratom and the relative safety and the drug concentrations that you find in individuals that do not show any signs of toxicity. So metragine is not an opioid based on its chemistry or its pharmacological class. As you heard, it does have some new opioid receptor activity, but lots of other complex pharmacology as well. And we've shown no respiratory depression in both animals and in our clinical study. However, consumers need to be aware that they should not be taking really high doses of kratom, and they should not be mixing it with other drugs. Thank you very much.
Good morning, everybody. My name is Kirsten Smith, and I am at Johns Hopkins University. This one?
On the right.
On the right. Which one? Okay, so I just want to make sure the clicker works. So I am going to be talking about people who, not in controlled studies, but just in America who use kratom. I've been studying this since 2017, and there's actually a lot of parallels with what we're seeing in the United States with actually what we see in indigenous use, including what Dr. Singh presented in Malaysia. So in the United States, kratom has actually been used for at least 20 years that we can have documented. In fact, Dr. Boyer had one of the first verified reports of use in the United States. And what we know is now, kratom is not just the botanical, right? So in America, we have a diverse set of products that are derived from this botanical, but there's actually a lot of consistency across these products. And we see that consumers are typically titrating kratom products to suit their needs, right? This is from a recent study, and I'm going to be showing several slides related to the study funded by the National Institute on Drug Abuse, in which we assessed kratom use among a national sample of people who have been using for a long time, most of them over a year. And what we see is that many people in the sample are using in a fairly regimented way. Some have a little bit more variability than others, but everyone kind of falls into their own kind of groupings of different use patterns. But what we don't see is binge-like use or heavy weekend use, things like that. And that the amount that people are taking are consistent. We have, again, really thousands and thousands of use events assessed with ecological momentary assessment. And we see a very nice, consistent and orderly pattern of use. Also, with respect to the products that people are taking, this is not published, it's under review, but the kratom products that people were taking in our study were analyzed in collaboration with the University of Florida, including Dr. McCurdy here. And what we see is that the alkaloid composition, so the chemical composition, was actually fairly consistent across products. It matched what we would expect for the species, the species of botanical. There was not any drug adulteration that was found, and that on average, the mitragynine or mitragynine, we all say it differently. We cannot agree on how to say it. Mitragynine, which is the major alkaloid, the most prominent alkaloid or chemical in kratom, the average intake was about 31 milligrams per use, and the mean daily intake was around 134 milligrams daily. 7-hydroxymitragynine, which is something we've not talked a lot about, it was really not found at all. It was trace amounts across products. And so what we're learning about this, again, this is a very complex botanical, so we can't unpack all of it, but this important constituent is actually not really found in kratom leaf or products that we've tested so far. So a lot of use is in keeping, kind of like how we drink coffee at different times of day. A lot of the use we see is very similar to that. Not a lot of intoxication. In fact, the DUI cases, we don't even have a lot of information about if intoxication was found. In my studies, we have not found intoxication. So we're not seeing people seeking out highs, but rather a lot of these immediate drivers of use, again, assessed momentarily, pain relief, improving mood, energy, focus, alertness. And then we also know that long-term people are using as a harm reduction tool, very similar to what Dr. Shan was discussing in Malaysia. We've seen very similar things in the United States with not only opioids, but also alcohol. Not so much methamphetamine, but alcohol has been a bigger one. We also see when we look at things like addiction or physical dependence, when we look at the specific criteria for meeting a substance use disorder for kratom, what we now call kratom use disorder, most of the symptoms you can see here on the right are basically physical dependence, right? So tolerance and or using to avoid withdrawal. And that's what we know can happen with daily use of many, many other substances as well. Similar to what Dr. Singh had discussed, the withdrawal symptoms are typically mild to moderate. This has been both in Southeast Asia and in the United States when people are reporting this, but it's only been very recently that we've had any empirical data. So I have one clinical trial at Hopkins right now in which people who've been using kratom for a very long time come in, and we do a lot of different assessments, but at the end, we tell them to stop taking kratom. And we are now assessing kratom withdrawal in an inpatient hospital setting, and it is in keeping with the self-report historically. So to conclude, after decades of use in the United States, kratom, this is, I think, a very important point. It refers to a very diverse set of products, right? So we have the botanical that's growing in Malaysia, Indonesia, and then we have the botanical in different kinds of products. So we always have to talk about what kind of kratom people are taking, but it is botanical derived, and it's a set of supplement products that are legally sold, which I don't believe really touched on much, but these are legally sold and consumed in a way that's pretty normative, right? So we need to do more research, but from what we can tell now, both the composition of these products and the way that people use them is converged into a fairly normative set of use patterns in chemical composition. And so that is what I will conclude with. Thank you.
Thank you, and thanks to each one of you. And before we go to questions, I'll invite Dr. Jack Henningfield if he would like to make a comment.
Sit up here.
Want to make sure the camera can capture you.
I'm Jack Henningfield. I'm professor adjunct at Johns Hopkins Medical School. And at Pinney Associates, I work on drug scheduling nationally and internationally. I've worked on drug scheduling nationally and internationally for 4 decades. I want to connect this to the CHEC session on Tuesday, because all of this is relevant to drug policy and drug regulation. This 1961 single drug and the 1971 psychotropic convention worked really well for new chemical entities. It's more difficult when applying it to old traditional substances. And we see that with kratom, we've seen it with cannabis and other things. The WHO Expert Committee on Drug Dependence in 2021 looked at kratom. FDA was among the organizations that said consider scheduling it. And WHO ECDD got it right. They said the pharmacology is relatively weak. It does not sufficient to indicate strong dependence potential. But they also considered the beneficial, traditional, and indigenous use. And they recognized that kratom is used, and there is a history of safe and beneficial use. We don't have that with new chemical entities. With new chemical entities, it's simple, it's just pharmacology. The FDA and some countries got it wrong. The FDA was misinformed or did not understand the pharmacology, as Dr. McCurdy and Kirsten Smith and others have explained to you, and they did not consider beneficial use. That's because for the Food and Drug Administration, beneficial use is only recognized for drugs that are approved by FDA. So it's true that FDA can say that kratom is not recognized as safe and effective as a drug. That is a fact. It is absurd to say that kratom is not used beneficially. And for beneficial use in the United States of America or globally, where that fact is well established, and you just heard some of the data. So what do we need for kratom? We have to recognize that nature got it right for kratom, and products that are true to nature have a history of safe and beneficial use. And to the extent to which products are adulterated or contaminated with heavy metals and toxins, or adulterated with kratom-related alkaloids or metabolites that are boosted to much higher levels in nature, or other substances, they shouldn't be marketed as kratom. That's simple. So all of what you've heard today goes back to what should the international bodies do with kratom? And my opinion is to treat it as a beneficial traditional product used by indigenous peoples and many others globally, and not as a new chemical entity that is dangerous. Thank you.
Thank you, Dr. Henningfield. And thanks to each one of you for these presentations. We're going to turn to a couple of questions. Apparently, there's a robust audience in the United States, despite the hour there, that is tuned in. And I've got several dozen questions that were texted to me, but I'm going to ask 2 of them, ask the scientists who feel comfortable responding, and then we'll go to questions in the room. The first is, the Tampa Bay Times did an expose on kratom deaths and claimed dozens of deaths in Florida alone. Is it true? They completely ignored my story The Kratom saved my life. Why?
Okay, I'll attack that one. So we got the autopsy reports from all of these cases. We analyzed them. First of all, more than 90% of them had less than 1,000 nanograms per mil of metragine, which I just explained to you. We have individuals walking around and doing quite well. Almost all had other important drugs present. Then the Tampa Bay Times states that. They list the other drugs that are present. They also, in the remaining drugs, the remaining cases that were over 1,000 nanograms per mil and that didn't, quote, have drugs, there were other drugs present in most of them. And there were seizure disorders, individuals with histories of seizure disorders. There were individuals with history of cardiac disorders. One individual actually died by strapping themselves into an inversion machine and then couldn't get out of it and died after extensive time on the equipment. So there were many, many of those cases that either contained extra drugs, had low concentrations, or had other causes of death. So we have investigated all of those cases.
Any other comments? Okay, second question, and this one I'm going to synthesize because there's so many of them. What is the difference in safety between kratom and 7-hydroxymetragine and metragine pseudodoxil products? I am scared to death when I read some of the labels on 7-OH products.
We might all have something to say about that. Do you want me? So I will give the clinical and maybe Ed can join that, and then Chris might have something to add to it. But so what we're seeing, just for those of you in the room in particular who might not have heard of these. So we talked about metragine. I mentioned 7-hydroxymetragine on one of my slides, noting that it was in most samples or products tested very trace amounts, right? So this is part of the botanical leaf that you don't in nature find a lot of this chemical constituent, right? So there are going back to novel psychoactive substances. This is a novel product that's been derived from kratom. And to answer the person's question, the main difference is that 7-hydroxymetragine is really not part of the kratom leaf, other than in a tiny, tiny amount. It's really a metabolite. And so what we've now seen in the United States are this proliferation of products, which are semi-synthetic products, and they are essentially acting only on the mu opioid receptor. So going back to kratom as a whole, it's acting on many, many, many different systems of the human body, whereas these are acting only at mu opioid receptors. And so what we're starting to see and have documented case reports of are 7-hydroxymetragine products that are causing physical dependence and addiction. And we will be publishing on that shortly, actually. So unlike kratom, which I showed earlier has some physical dependence, but not a lot of addiction, these products, we believe, are kind of the flip. We'll see a lot of addiction and dependence. And I think that, for me, in my work, is the most important part. There might be some medical doctor stuff that Dr. Boyer will want to add to that, as I only study addiction.
Yeah, I mean, I guess the only thing I'd add is, we've got publications, both that we're writing up and have been submitted already, where individuals progress from initiation of 7-hydroxy use to frank addiction within 2 weeks. So there's a clear risk. It's a potent MOR agonist, and it is short acting, and we were able to demonstrate variability in the concentration from the labeled amount of 7-hydroxy that the manufacturer says in there. So if you underdose and take a unit dose of a material, if you get a smaller amount of material and you have to redose, now you get a much larger amount. So it's the imprecision in manufacturing, the short duration of action, and the potency of binding that really drives 7-hydroxy towards addictive use rapidly.
And the more frightening piece, not only from just the active ingredient piece, is that these are being produced in a way that is chemical synthesis. So what's happening is the manufacturers are taking, and now this has been documented on YouTube as well in interviews with the manufacturers. They're taking concentrated alkaloid extracts, and so they're getting high amounts of mitragynine in those extracts, and then they're chemically oxidizing those with oxidants. Most commonly used in large scale is what's used to shock swimming pools. So they're using large amounts of materials like this, then they extract that with essentially sodium bicarbonate, which you can also buy on large scale from cooking places. And then what they're doing is extracting this entire oxidative product of the reaction and putting that into the tablets. So there are several unknown molecules within that product that's being sold and then ultimately ingested by consumers in the United States. Our concern, and we've purchased some of those products with our own money and analyzed those to see what the presumed adulterants would be, because these are not known substances at all. We know that 7-hydroxymitragynine is present in those products. We know that mitragynine is also present because the reaction is not a one-to-one conversion of mitragynine to 7-hydroxy. There's always mitragynine left behind. But then there's at least 8 other new, probably psychoactive substances that we have no idea what they are. And so the threat to public health is not only one of 7-hydroxymitragynine being a mu-opioid receptor agonist, that every single mu-opioid receptor agonist has abuse liability that I've run into in the decades that I've been researching opioids. I've never seen one that doesn't. And they all cause respiratory depression. And so we have a paper that's just about to be submitted showing the respiratory depressive effects of 7-hydroxymitragynine, clearly linking it to being a danger in and of itself, along with all the unknown compounds that are present in those products. I think the last piece on this that I wanted to address was the mitragynine pseudoindoxil, which is a compound that is not even known to exist ever in the plant. This compound was actually made by a fungus where they fed isolated mitragynine to the fungus. The fungus does chemistry. It metabolizes things just like any living substance, and it spits out a new chemical entity, and it happened to be this mitragynine pseudoindoxil. When that was tested, it's also a very potent mu-opioid receptor agonist. It also turns out to be a metabolite of 7-hydroxymitragynine in mammals. And so 7-hydroxymitragynine is well documented as being a metabolite of mitragynine in not only the intestinal tract, but through the liver of species. Doesn't matter what mammalian species it is. Humans tend to produce the highest amount of 7-hydroxymitragynine versus other species. And then pseudoindoxil is actually produced as a metabolite of 7-hydroxymitragynine. And so you can imagine that if you can create it semi-synthetically from oxidation of mitragynine to 7-hydroxy, you can also take the 7-hydroxy mixture and oxidize that even further to create this mitragynine pseudoindoxil.
Yeah, one thing I need to add, if you're ever at the bedside of somebody who's used a substance, you got to figure out what they're taking. If you go into a store, people are likely, in the United States at least, are likely to say, this is a 7-hydroxy product. It's from Kratom. So the vendors intentionally blur the distinction between 7-hydroxy and Kratom, but the situation's even worse. If I am working at the bedside and I have somebody who comes in and tells me I use 7-hydroxy, and I call my poison control center and I say, I've got a patient who used 7-hydroxymitragynine. Let me spell that for you. And the specialist enters it verbatim into the computer system that poison centers use. Up until 3 weeks ago, it default coded to Kratom. So adverse events associated with Kratom were intentionally miscoded. So you really have to be precise in the questions that you ask when you are trying to figure out what somebody has used.
And I just want to add that when we did our study on the slide, I showed you the maximum 7-hydroxy concentrations. So we measured that, and it is a metabolite, as Dr. McCurdy said. And you can see in our manuscript what the normal concentrations are in humans from metabolizing metragine. This is a totally different subject, taking this synthetic 7-hydroxy product with unknown constituents. So the normal data you can see, and then this is a new product with a lot of associated toxicity.
Thank you. Let's turn to those in the room. Are there any questions that any of you might have for these experts?
Okay, I don't have the opportunity to ask these questions very often, but I have a question for Darshan.
Yes.
Can you tell me what is the difference between different strains of nitrogen plants, like say, except for example, Nitrogena speciosa, we have Japonica. Is there anything that differentiates them? Or
Okay, so it's like that. Me as a social scientist, I've actually gone to many places and we've actually saw different species of kratom. And in fact, one of our faculty members worked very closely with Christopher McCurdy. And over the years, we have seen there are differences in the alkaloidal content of kratom leaf material that is coming from Indonesia, Malaysia, and Thailand. But there is no proper documentation of that, but we get to see there are significant variations in the alkaloidal content. Probably Prof. McCurdy, you could actually add a little bit since you work very closely with.
So there's been reports historically in the literature that Mitragana speciosa was the only Mitragana species that produced mitragynine. That was because back when those publications were made, there was not actually the detectable limits where they could find those alkaloids. So now we know that mitragynine is present in some of the other subspecies as well, but in extremely low amounts. We've done extensive DNA mapping of the different species of the genus Mitragana now, and what we're learning is that many of the products actually include what seems to be a hybridization of Mitragana speciosa combined with, parvifolia, I believe. And so what's happening is, what we're seeing is some plants that we were actually analyzing, and we have a paper where we grew Mitragana speciosa in the USA back in the early 2000s. And we did not find levels of mitragynine in those trees that were comparable to what has historically been reported. We didn't know any better at the time. We just thought we had some strange variation of the plant, but mitragynine was definitely being detected. Now we see in trees that we have actually sampled with GPS coordinates in Malaysia, that same pattern. So we can see some trees that are producing extremely low levels of mitragynine and others that are producing some of the more historically reported levels. And that really piqued our curiosity because these trees are growing right next to each other. They're being harvested, they're being blended, they're being made into the same decoction that people are using daily. So what's the difference? So we went back to the genetic patterns of these, and we've just completed the whole genome for Mitragana speciosa, which will be published. And we're in the process of completing whole genomes on Parvifolia, Hirsuta, and the Versifolia as well. And so we're going to start to learn a lot more about what the genetics are encoding in terms of the proteinomics and the transcriptomics that end up producing the enzymes, the biosynthetic enzymes that end up producing the secondary metabolites in the plants. So we're talking about something that's way deeper dive than just the pharmacology, but it's very fascinating.
Well, thank you very much. We've reached the end of our assigned time in this room. We will be circulating a video of this presentation. and a summary of the conclusions that are presented by these independent experts. I know you wanted to ask a question. I'm going to give you a chance to do that.
Sure.
Please.
Okay, I have four, so which one do I ask?
Ask
The
two,
most
ask
important
two.
one.
We have 2:11.
Well, as long until they open the door and throw us out, then we'll leave.
Okay.
Okay, very quickly. So my knowledge of kratom is very little, so I have so many questions because of that. How do you get it in the US? Because for us, you have to go to the deep web, and people who use it are usually looking for like a new fixation or a new trend, and that's how they order the kratom. And I know there is a huge history in Malaysia, but how is it in the US?
So you can purchase, basically online is the best way, but not the dark web. It's
Okay.
just the
Very
regular Google,
accessible.
yeah. But then also in shops, so primarily in like stores that sell like nicotine or vaping, things like that. It's not yet in mainstream like health shops or grocery stores. You cannot purchase it there, but you can purchase it in all but 5 states. It's legal. And so you just have to kind of go to a specialty shop.
Okay,
Like where they sell CBD.
yes.
Frequently.
Yeah, perfection. Okay, second one is, does it help with the opioid withdrawal because it eases the symptoms, or is it the similar fixation of the usage? Because I know, for example, people who are addicted to nicotine, they are usually addicted to the ritual of smoking, and they find another ritual to replace it. Does it help because it eases the symptoms, or is it a similar using again and again and again the tea and stuff?
I think, so I'll speak to America and Darshan can speak to Malaysia. So in the United States, we've had several opioid epidemic waves. And so beginning with prescription opioids and then heroin and now fentanyl. We have the most data on the prescription opioids and heroin. And obviously you cannot inject kratom or kratom products at all. You can only drink or eat it. So the actual route of administration is very different than what people are usually doing. And unlike nicotine, where you're smoking or vaping many times, heroin or oxycodone or whatever, you're taking it a couple of times a day. So with kratom, we do see 2 things. One, attenuation of opioid withdrawal symptoms acutely. And that has been very well documented, but also for a portion of people, they're using as a long-term opioid and alcohol substitute. But what I think is very important and what we have good information about is that most people, in fact, nearly everybody uses kratom for multiple reasons, not one reason. And so someone might want to start using it to not use opioids, but they're also using it for energy, some focus, because again, it's not an opioid, right? So you have these other properties. So with like a maintenance medication like buprenorphine is very, very different. So what we see with kratom is that it becomes part of a lifestyle thing. And many people who are not using it for a replacement or harm reduction use it for energy and stimulatory purposes, like even like to go work out at the gym. So it's multiple things, and it's not necessarily replacing one addiction for another, if that makes sense.
Yeah.
And Darshan.
Yeah, just to add on, like, for example, in Malaysia or within the Southeast Asian region, you get to see heroin, it's widely abused, right? So I've been working with patients, for example, heroin users, they use kratom is because they want to reduce their dependence on heroin. So kratom also help to suppress withdrawal symptoms. And it's up to them whether you want to use kratom or not to actually maintain your abstinence. So there are people who use kratom, but in a very moderate quantity. So they are not actually addicted to kratom. They just use to make sure that kratom helps them, help to prevent them from using heroin again. And there are people who have actually successfully been weaned off from heroin. So they don't use heroin anymore. They just use kratom for very short term. That's the end. They don't go back to heroin either way. Yeah.
Okay. Let me interrupt you for a second. You had a question in the back, and then we'll come back to you.
Yeah, I was wondering if there's any clinical research on the horizon using kratom. Sorry,
Yeah, so I'll say, yeah. So
for anti-anxiety effects, like
For
anti-benzodiazepines.
Well,
No, just ADHD also, not just anxiety, because I think ADHD would work for ADHD, because I have ADHD, and everything you're describing sounds amazing.
I'll just briefly say, so it does not act like a benzodiazepine, but people do use it for anxiolytic effects and also for focus. So it sounds almost contradictory that it has all of these different properties. It almost sounds crazy, but we do have reports of use for ADHD and for anti-anxiety.
So that is how I use it as an alternative to benzodiazepines.
Yeah.
Yeah, I would love to see research happening in that way.
We will get there. It might take a very long time. I think it's,
Can I just add to Dr. Smith's comment? It's not crazy. Most drugs have diverse effects. Amphetamine can be used to wake you up. It is used to slow down ADHD behavior. Nicotine is used to relax and energize. This is not novel to kratom and
Yeah.
mitragynine. It's pharmacology, it's individual differences, it's the dose.
Yeah, and low dose opioids can actually stimulate
Yeah.
respiration, so.
it makes it more toxic.
And one thing I didn't say in my talk that as Dr. Smith was talking, after the 15-day multiple doses, we showed no abuse liability at all. No withdrawal, no abuse liability in the study.
Okay, last question, and I combine the last two, is how is it to synthesize in a lab? So like, I'm thinking about how they are making cannabinoids in a lab now and how they are misusing it. So my question is it easy to synthesize in a lab? And if you can do that, how would they misuse it like they are now using methazine with cannabinoids?
Yeah, so the total synthesis of the alkaloids is over 25 steps.
Yeah.
So it's really not commercially viable at all
Okay.
to do this. And just as a comparison, all of the commercially used opioids, clinically used opioids, are still isolated from the poppy plant. And so there's no real way to make these synthetically and put them into commerce. That it just doesn't make sense. The products that are being put into commerce are being made semi-synthetically. So semi-synthetically means they have the material to start with, and then they're converting that material, like I explained. They'll take these very concentrated mitragynine extracts and then oxidize that to produce the 7-hydroxy or the other one. So it can be done in the laboratory. It's being done in laboratories, and then those laboratory results are being essentially formulated, packaged, and put into products.
Yeah, and what's your suspected like misuse?
These are very new products. What we've been doing, we have a system in the United States called the National Early Drug Warning System. And we've been tracking. What that does is tracks Reddit, it tracks other areas to see discussions and mentions of substances. And we've seen actually exponential increase in the discussion around 7-hydroxy, which definitely also mirrors the sales of those products that have really taken over the marketplace, over the fresh leaf materials, I would think. And so it's pretty indicative that there's probably some issues going on with use, abuse, and misuse for sure.
Dr. Boyer.
You know, talking about 7-hydroxy and the desirability of it, I go a bunch of different places. I went into a cannabis dispensary just to see if I could buy 7-hydroxy right around the corner from my office. And the people there said, "Oh no, we don't have it." I said, "Really?" And they said, "Yeah, somebody broke into us last week. They didn't take any of the cannabis. They didn't take any of the. They didn't take anything. They took only the 7-hydroxy products." So, it's got some street economy associated with it. The other thing I wanted to say, and I don't think it's come out in this talk just yet, you don't have to talk to somebody with addiction for very long, and you hear that they've lost their house, they've lost their job, they've lost their family, they've lost their income, they've lost their savings. A lot of times folks are resistant to going into drug treatment because the only thing going right in their lives are the drugs. The world is on fire around them. The only things working as it should are the drugs. You don't have to talk to kratom users very long before you hear, "You know what? I am back home. My family's accepted me. I'm holding down a job. I'm paying more attention to my family." And then what so many people have told me is it's a miracle drug. So can there be issues with the use of kratom? Of course there can. Can you develop addictive use of it? Physical dependence. She always corrects me. Can you develop physical dependence to it? Of course you can. But it seems to be fundamentally different than other types of problematic substance use.
Well, thanks to everyone. We want to get invited back, so we'll vacate the room. If you have additional questions, you can submit them on americankratom.org. We'll circulate them to the experts and we'll get the answers back to you. Thanks for everyone
Thank
being
you
here.
so much.